Alright, in question 6, we're asked then to study the graphs below and outline what impact the standard deviation has on a normal distribution curve. And this was, there was an error in the question. Hopefully you spotted it, but if you didn't, I'll talk you through it now. The numbers were labelled incorrectly, and I didn't catch that. So I'm going to label them correctly for you now. This one would have a standard deviation of 12. This one would have a standard deviation of 8, and this one would have a standard deviation of 3. So maybe just pause the video now and see, can you pull out or discern the pattern? So hopefully you've had a bit of time to think about it, but the larger the standard deviation, so the larger sigma is, the more spread out the curve is. Okay, the more spread out the curve is. That's the pattern we should have been looking for. So apologies if that caused you some confusion today, but it is in your book. You should be able to read up about the standard deviation. Here's an even better example of that, and an even clearer one that I should have used in that worksheet for you guys. So it's SAT scores. You can see they all have the same mean. If I draw a line down the middle here, they're all peaking at roughly or they are actually all peaking at the exact same point, just about 1,000 here, but they all have different standard deviations. So the blue curve's got a standard deviation of 80, and it's quite narrow, the spread of it. The next one is 120, a larger spread, and then the next one is 190, so an even larger spread again. So for that one, question 6, the pattern is that the larger the standard deviation we have, the more spread out our curve is going to be, the wider that curve is going to be. So that's what we were looking to start talking about there, and that then allows us to start talking about the exam paper question that we had, which is from 2013. So in 2013 we were asked about the heights of a certain type of plant, and when ready to harvest, they are known to be normally distributed with a mean of mu. A company tests the effect of 3 different growth hormones on this type of plant. The 3 hormones were used on a different large sample of the crop. After applying each hormone, it was found that the heights of the plants in the samples were still normally distributed at harvest time. The diagrams A, B, and C on the next page show the expected distribution of the heights of the plants at harvest time without the use of hormones. The effect on plant growth of each of the hormones is described on the next page. Sketch on each diagram a new distribution to show the effect of the hormone. So I'm going to zoom in here and we take a look at what they're saying, and then we're going to sketch out what's happening. So that's the normal distribution curve before the effect of the growth hormone, but in hormone A, the effect of hormone A was to increase the height of all of the plants. So the curve is going to shift, and so is the mean. So our mean's actually going to be along this line now, but it's still going to be normally distributed. So we try and keep it the same height, and we try to keep our symmetry as best we can. So we're going to have a shift of all of them with a greater mean. You could shift it up even further if you want, but the idea is that the mean is shifted, so the peak of the graph is shifted, and it's still normally distributed because all of the heights have been moved. The next one, the effect of hormone B, was to reduce the number of really small plants and the number of really tall plants. The mean was unchanged. So basically we want less plants in this section and less plants in this section, but we're not changing the mean. So what we are changing is the standard deviation. We're changing how far away the data is. So we're going to get still a normal distribution curve, still with the same mean, but we're going to get this kind of squashed up curve, this curve with a less of a spread as a result, because what we're changing is sigma. Sigma is getting smaller, the standard deviation. And the last one then, part C, the effect of hormone C was to increase the number of small plants and the number of tall plants. The mean is unchanged. So again here, actually, what we're changing is sigma. And what are we doing? Well, we want to make this even larger. So these sections here, we want to increase them. And where are they going to be coming from? Well, we're taking them off the middle and we're spreading them out. So we're going to actually get this more spread out curve. So you're going to get a wider curve like this. Okay, so similar to what we had up here, this more spread out curve with the same mean. So it's not going to be as high up because the area from here is being transferred into these regions down here. Okay, so hopefully that gives us a nice little understanding of the normal distribution curve and the impact that changing the mean and the standard deviation can have.